All right, guys, we are going to go through a few of the problems from Newton's second law. It's a little packet. This first page you should be able to fill out completely with your notes, but what I do want to do is help you with a few of these problems. So if you want to go ahead and flip, we're going to do a couple problems from each page. So on this first sheet, we have an unknown force, we have a mass of 5 kilograms, and we've got an acceleration of 2 meters per second squared. So first we need to find the equation for force. And force is equal to mass times acceleration. So all we need to do is take the mass, which is 5 kilograms, so 5 kilograms, and multiply that by the acceleration, which is 2 meters per second squared. 5 times 2 gives us 10. Now remember, force is not measured in the units F. It's not measured in the units G or kg. It's measured in the units newtons, okay? And newtons is the same thing as saying kilograms times meters per second squared. It helps us out so we don't have to write quite so much. All right, let's do this second one. Again, we have an unknown force. We have a mass of 12 kilograms, and we have an acceleration of 3 meters per second squared. So if we know that force equals mass times acceleration, we just need to plug these in. Force then equals 12 kilograms times 3 meters per second squared. 12 times 3 gives you a force of 36 newtons. All right, let's go to this next one. Here we are given force, but we don't know the mass, and we know the acceleration. This is the way I remember how to do these equations, okay? Imagine a triangle. We know that force is equal to mass times acceleration. And I want you to think about this. We've got force over mass times acceleration. So when we're looking for force, you can see that there's mass times acceleration. When we're looking for mass, what do we have? Force over acceleration, or force divided by acceleration. When I look for acceleration, I've got force over mass, or force divided by mass. So for mass, cover that one up, is force divided by acceleration. So mass is equal to force divided by acceleration. So all you have to do is you take 100 newtons divided by 20 meters per second squared. 100 divided by 20 is 5. Now let's think about those units. Mass is not measured in a distance, so it's not going to be meters. Mass is not seconds squared. Seconds is time. What would mass be? Do you guys remember how this says kilograms times meters per second squared? That's the same thing as newtons. So this is the same thing as saying kilograms times meters per second squared. If we had that, these would cancel out and we would be left with kilograms. So the answer is 5 kilograms. All right, let's do one more mass problem. We've got a force of 0.50 newtons. We've got an unknown mass. We've got an acceleration of 2 meters per second squared. And I want you to remember this. So cover up the mass, and you've got force divided by acceleration. So mass is equal to force divided by acceleration. All you're going to do is you're going to plug in the force, which is 0.50 newtons over 2 meters per second squared. When you plug this into your calculator, you're going to do 0.5 divided by 2, and you will get a mass of 0.25. Now, what units am I going to use? Remember what I did over here. Newtons is the exact same thing as saying kilograms times meters per second squared. So we would be left with kilograms. And think about it. Kilograms is the only thing that makes sense. Meters measures distance. Seconds measures time. Newtons measures force. So kilograms is the only thing that actually measures mass. All right, let's do a couple of acceleration problems. For this acceleration problem, we are given force, we are given mass, and we do not know the acceleration. Now again, when we're looking at this, if you cover up acceleration, you have force divided by mass for the equation. So acceleration is equal to force divided by mass. So all we have to do is acceleration. We've got 18 newtons for force. We have 3 kilograms for mass. Type that into your calculator. You have 18 divided by 3. You get 6. Now, how do we measure acceleration? Look at all these other acceleration problems. Meters per second squared, meters per second squared, meters per second squared, meters per second squared. So it would be 6 meters per second squared. All right, I'm going to let you guys solve this problem on your own, but I do want to go through one of these word problems. You know that whenever we're solving for force, mass, or acceleration, we are going to need to know what the force is, what the mass is, and what the acceleration is. So anytime you're doing one of these problems, I'd recommend writing out those variables. So a 4-kilogram ball, what is this measuring? Kilograms. Measuring the mass, so you can write 4 kilograms. Is pushed with a force of 44 newtons. 44 newtons. Calculate the acceleration of the ball. So we do not know the acceleration. Remember, how are we going to solve that problem? You've got your triangle, cover up the A. Force divided by mass equals acceleration. So force divided by mass. So that would put us at 44 divided by 4. 44 divided by 4 gives us 11. What is the unit for acceleration? 11 meters per second squared. Exactly right. All right, let's go ahead and go to the next page. Go ahead and flip that over. We're going to do a few from this page, and then we'll be done with this worksheet. For this one, I want to go ahead and start with the mass, okay? So anytime you guys see weight, weight is equal to mass times gravity. And gravity is equal to 9.8 meters per second squared. Gravity is actually just the acceleration of Earth, okay? So whenever you have weight, it's mass times gravity. That's why when I say weight and mass are not the same thing, this is very specific because if you're on the moon, your weight isn't going to be the same. Your mass is going to be the same, but the acceleration of the moon or the amount of gravity that's on that other planet does not have the same impact on your mass, making you a different weight. So calculate the weight in newtons of a 50-gram student on Earth, 50-kilogram student on Earth. So we know that the mass is 50 kilograms. We also know that gravity is equal to 9.8. So all we need to do is weight is equal to 50 kilograms times 9.8 meters per second squared. And we get that the weight is 490 newtons. There's your answer. If you guys need any extra help, come on in, ask me, and the key is also attached. Thanks.